Okay, Trig, this is section 12, let's see, 12.1. This is the second half of it, so we've done the rest of it above already, and now we are on to example 7, 8, and 9. We've just got those 3 left to do. This is a 3 by 3 system, which I don't think we've done one of those yet, but it's not terribly hard to solve, just a little bit more intricate. And then we've got 2 story problems, okay? So that's all we have left, and then we'll talk through some of the homework and we'll be good to go. Example 7, they give us 3 equations for x, y, and x, y, and z in each one of them. And what we want to do is we want to combine those equations somehow so that a 3 by 3 becomes like a 2 by 2, okay? So one thing that I notice is that if I were to add these 2 equations together, like doing the substitution elimination, like the elimination thing, if I add those together, like the z's are going to cancel because I have a minus z and a plus c. So I'm going to go ahead and do that, and I'm going to take, if you need a little note here, this is equation 1 plus equation 2, okay? So that's what I'm doing here. And if I do that, 2x and negative x is just going to become x. The y's, I will end up with negative 2y. The z's are gone now, and then I'll end up with 4, okay? Now, if I do that, I want to add 2 other equations together. So it doesn't have to be the second one and the third one. It could be like the first one and the third one. I'm going to do the second and third, I think. But I have to add those 2 equations together and do some sort of elimination so that the z's go away as well. So that way I have 2 equations here that only involve x and y, okay? So what I'm going to do is I'm going to multiply this middle equation by 2. I'm going to do some side work over here. If I multiply that middle equation by 2, I get negative 2x minus 6y plus 2z equals 5. And then I'm going to put this one right below it, the third one. So x plus 4y minus 2z equals negative 10. And now I have it where my z's will cancel with each other, okay? So I end up with negative x minus 2y equals negative 5. And I'm going to put that down here. Negative x minus 2y equals negative 5. I've got that going on, okay? Now, one thing, let's see, I can put this little note right here, is that what I did was I took row 2 times, let me write some stuff out here. So this was just row 1 plus row 2. So I was adding these 2 rows together, okay? Then to get this guy, I took 2 times row 2 and added that to row 3. So that's how I wrote those, okay? In section 12.2, we're going to be dealing with like this kind of similar notation. So I'm going to write it out that way so you get kind of exposed to it today, and then you'll be a little bit more familiar with it tomorrow. So, all right, now I'm going to use my elimination to do this one. So I know that the x's cancel. This will become negative 4y equals, that's negative 1. Okay, and let me make sure I didn't do anything wrong here. Problem. I see my problem. When I multiplied 3 by 2, yep, I didn't multiply my 5 by my 2. So that should be 10, in which case this should be 0. There we go. Okay, I didn't think it was going to come out as a decimal number, although that's always an option. But 0 should be that number there. And then if I divide by negative 4, 0 divided by negative 4 is 0. So I'm just going to plug 0 in. Now, all you do is as soon as you find one variable, you're going to work backwards. So I'm either going to plug into one of those 2 equations, plug the y in, and then I'm going to take the x and the y and plug them into one of these up here. And it doesn't matter which one you choose. I'm just going to choose this top one right here. So I have x minus 2 times 0 equals 4. 2 times 0 goes away, so x is 4 in that case. And that's what I have there. And now I'm going to plug into one of the other equations. I'm going to do this middle one because z is already positive there, and I won't have to divide by a negative or anything like that. So I'm going to go negative 4 minus 3 times 0 plus z equals 5. That's what I've got going on there. Okay, so I'm plugging those numbers into here and solving for z. All right, so negative 3 times 0 goes away. I'm going to add the 4 over, and z equals 9. Okay, so my ordered, it's called an ordered triple instead of an ordered pair, is 4, 0, 9. And what this means is that these three things are still like kind of like linear functions, but they're like out in space, that are like out in 3D space, that are like going every which way, whatever, and the place where they all meet up is at the point 4, 0, 9. So imagine that this is in 3D space and you have some that are coming from different directions, whatever. 4, 0, 9 is where they're going to intersect, is how that works. Okay. All right. Example 8 is a 2x2 like story problem. Okay, so a ball game is attended by 575 people and total ticket sales are this much. Okay, we have two different types of tickets and they are adults and children. So I'm going to say adults and children. We're talking about the number of adult tickets and the number of child tickets, and the number of each one of those is going to add up to be 575. Okay, now of money, I take the number of adult tickets and I multiply that by 5 because that's how much they are worth. And then I take the number of children tickets and I multiply that by 3 because that's how much those are worth. And the total worth of those two added together has to be 25.75. Okay, and those are my two equations that I'm going to use, and then I just have to solve. So I can do substitution or elimination with this one. It doesn't really matter. I'm going to, let's see, I'm going to multiply through by a -3, I think, to eliminate the c value. So I can solve for a first. So I'm going to do that portion. All right, so -3a minus 3c equals, oh, I got to do some math here. 575 times 3. And that is -1725. And I'm going to add these two equations together. So this will become 2a. The c's are gone. And 2575 minus the 1725 is 850. And then I'm going to divide by 2 and solve for a. And that will give me 425 adult tickets. Okay, now if there's 425 adult tickets and I know that adults plus children is 575, 425 goes in for a, 575. I can just subtract the 425 from the 575. Maybe you probably could have figured that out without actually writing out the equation, but I'm just showing you all the work here. C equals, that will be like 150 children tickets. So that is my combination for child tickets and adult tickets. Because we're not dealing with X's and Y's, I'm not going to write it as an ordered pair. You could if you wanted to. Why do I have two equal signs? I have no idea. Okay. There we go. I'm not going to write it as an ordered pair like 425, 150 because I don't know which one necessarily goes first. I'm just going to leave them like that because they just asked me for how many adults and how many children. Okay. All right. This next one, example 9, is a mixture application. All right. So we've got some information here, just kind of like we did in the last one. Let's see what we come up with. A cafe sells 2 kinds of coffee in bulk. The Costa Rican sells for $4.50 a pound, and the Kenyan sells for $7 a pound. The owner wishes to try a blend that would sell for $5 per pound. How much would each type of coffee, how much should each type of coffee be used? Okay, so here's the deal. The key here is, and this is kind of confusing, they're talking about per pound, okay? So I want it to end up eventually being $5 per pound. So that means my Costa Rican plus my Kenyan blend has to be equivalent to 1 pound, okay? So like whatever amounts that I have of each one has to be equivalent to 1 pound, okay? Then our second equation is going to have to do with the price. I'm going to use a $sign. A $sign times the amount plus $sign times the amount is going to give me $sign times amount. Okay, so here's the deal. I want to eventually end up with $5 per pound where the amount is 1 pound, right? The Costa Rican is my, let's see, okay, $4.50 is my Costa Rican blend, and we don't know the amount for Costa Rican, so I'm just going to put CR. I'm going to use that for my variable. You can use X and Y, I don't care. Plus the $7 for the Kenya blend, and we don't know the amount. So we don't know these amounts here, but we do know the amount at the final end is per pound. That's $5 per pound. That's where the 1 comes from, okay? So really what I have going on is I have this equation here, and I have this equation here going on, okay? So that 1 was a little tricky. He was kind of hidden in there a little bit. I'm going to write these better. CR plus K equals 1. And I'm just going to say 4.5 CR plus 7K equals 5. Okay, so those are going to be my 2 equations that I have, and then I'm going to solve. Okay, I always like to do elimination if I can. You go ahead and do substitution if you want to, but I'm going to do this, and I'm going to multiply this top one by -7 to get rid of the K. Okay, so -7 CR minus 7K equals -7. Okay, and then I have, this will become negative, I gotta think now, 2.5 CR. The K is gone, and this will be -2. If I divide by -2.5, that'll give me the amount for the Costa Rican blend. So for the Costa Rican blend, I want, the negatives are going to cancel, 2 divided by 2.5, and that is 0.8, and that is in pounds. So I want 0.8 pounds. Now, I know that the pounds have to add up to be 1, so you can do a little mental math if you want to, or you can write the equation out, I don't care. I would need 0.2 pounds of the, Kenyan blend, in order to make 1 pound. So that was a little tricky coming up with those equations, just because the per pound thing made this 1 kind of hidden in there, okay? But I call these like nickels and dimes problems, because a lot of times you're saying like a jar of coins has this many nickels and this many dimes, and that's kind of like what these are set up as. So a lot of times you'll see nickels and dimes problems, for example 8 and 9. So there is that. That is substitution and elimination, first with 3x3s and then a couple story problems. And homework, you should be able to, I think you should have probably hopefully started on this front side, and then the back side is where you have 2 things happening. Now you might have, I want to say you have some weird things happening, like you might end up with no solutions on one of them, just a little hint, or infinitely many solutions. I don't remember. One of them has something weird. And then here's some story problems that go along with that. So do the best you can. There you go.